Welcome back, chemistry students. In the previous lesson, we had a look at some polyatomic ions. In this lesson, we are going to look at how to use these polyatomic ions to write a chemical formula. There you go. Alrighty. So let's say we want to write the formula for the following substance. For example, sodium sulfate. Now, first of all, sodium we can find on the periodic table. It is in group 1. So, if we go and write the formula for sodium, it will be Na. Because sodium is in group 1, it means it will have a positive valency because it is a metal. Metals are on the left-hand side of the periodic table, and group 1 will definitely be a metal. And because it is in group 1, it will be positive 1. So this is the valency for sodium, positive 1, and the ion is Na plus 1. Now, sulfate, on the other hand, is a formula that we have to go and study off by heart as per the previous lesson. And sulfate is SO4 minus 2. Now, we need to use this information to write a chemical formula. How do we do that? Right. We look at these two separate ions, the one which is a positive ion and the one which is a negative ion. Because it is two ions combining, one positive and one negative, we are forming an ionic compound or a salt. Right. Starting off with the positive one, we write down the formula without the valency. Then next to it, we write down the negative one without the valency. What we then go and do is we look at the numbers only of the valencies, the exponents, only the numbers. The 2 from the sulfate then goes to the sodium, and not as an exponent, but now as a footscript. And the 1 of the sodium now goes to the sulfate, not as an exponent, but as a subscript or footscript. And because it belongs to the whole of SO4, not just the O4, we have to put brackets. The positive here just means that this one will be written first, and the negative means that this one will be written secondly. But because this is a 1, we do not have to write a 1 in math and science. We can leave that one out, and therefore the whole set of brackets will fall away as well. That leaves us with Na2SO4. Let's look at another one. Let's say we have to write the formula for magnesium hydroxide. Now, magnesium is in group 2, and it's on the left-hand side of the periodic table, which means it is a metal and positive. Positive 2 because it is in group 2. Hydroxide is a polyatomic ion that you need to go and study off by heart. Then, let's go and swap the valencies. There you go. Because magnesium is first, it is a, let me just get this pen. Magnesium is a metal, therefore it goes first, it's the positive part. And hydroxide is a negative part, so it comes second. All right, the number only of hydroxide will be written as a footscript next to magnesium. Oh, that was a 1. All right, and the number only of magnesium will be written as a footscript next to the hydroxide, but not just the H, but the whole hydroxide. Therefore, it will be Mg1 OH in brackets 2. But we do not have to write the 1, so we can just leave it as Mg OH in brackets 2. Let's look at another one. Let's write the chemical formula for lithium phosphate. Lithium is in group 1. It has a valency of +1. Phosphate is PO4 -3. We go and swap the valencies. There you go. We write down lithium first because it is the positive one, and phosphate second. Just note this is one term, one word type of thing. There's no spaces. Phosphate has a 3, which comes as a footscript next to lithium, and a 1 next to the phosphate, which is invisible, and we do not have to write it.